velocity as maximum. So maximum velocity when time equals 1. So if we put in t equals 1, then we are going to end up with a plus b equals 0.1. That's going to definitely be one of the equations. We've got to determine a and b. Velocity is a maximum. So if this is velocity, maximum is going to be if we look at the gradient function. So if we look at dv by dt, then we're going to end up with 4a t cubed plus 3bt squared. And again, it's maximum when t is 1. So that gives us, that's going to equal 0. 0 equals 4a plus 3b. So determine the values of a and b, which means that we can combine these two, or looking at them. So if we solve them simultaneously, we've got 4a plus 3b equals 0, and 4a plus 4b equals 0.4, and take them away. B equals 0.4, which means that A must equal 0.4 minus that, so it is minus 0.3. Determine the values of A. Find the time at which the particle changes direction. So the particle changes direction when v equals 0. This is for part 2. So we're looking for when v equals 0. So 0 equals negative 0.3 t to the 4 plus 0.4 t cubed. I'm just going to change this to fractions and bring it to the other side. So we end up with 3 over 10 t to the 4 equals 4 over 10 t cubed, which means that we get 30 t to the 4 equals 40 t cubed. I may have moved that for no reason. So we end up with 0 equals 40 t cubed minus 30 t to the 4. I just realised I didn't need to do that at all, but anyway. So we can now factorise this. So we take out t cubed, we end up with 40 minus 30 t, which means that t is equal to 0, or t equals 4 over 3. It's supposed to be a 4, so t equals 4 over 3. Yeah, sorry, I went a long way around getting to that answer, but it's getting late at night. That's what my excuse is anyway. Explain why the model would not be suitable for large values of t, because this would suggest that the velocity just keeps on increasing. So that would be the reason why.